Hey guys, this question would like to know what is the major product formed in the reaction shown. Okay, so we're given an alkyl halide, which kind of tells us we're doing, one of those SN1, E1, E2, SN2 type reactions. Okay, I'm just guessing, just looking at that already. And I see that I'm adding a base and heat. Now when I hear that, a base and a heat, that tells me I'm going to do E2, right? Because a good base won't want to do substitution. It definitely favors elimination, right? And heat, an E1 doesn't use a base. E1 uses like a polar protic solvent, like methanol or ethanol, or sometimes even acids in the case of if you start with an alcohol. So base definitely means it's going to be E2. Okay, so E2 is going to be a reaction, and if we look at our products, it's all alkenes. That's why we know we're doing an elimination for sure. All right, so now here's the tricky part. E2 has a stereochemical requirement about it. It's stereo-specific. What does that mean? It means that before I can rip off the proton, what is known as the beta hydrogen, next to the bromine, right? So here's the bromine, and this hydrogen here. Before this base will rip it off, let's draw the mechanism just so you kind of know what exactly happens, right? It's a one-step concerted reaction. You get the alkene plus the hydrogen added to the base plus the bromine as the leaving group, okay? Before this can happen, this hydrogen and this bromine need to be what is known as anti-periplanar to one another. That means they have to be in the same plane but pointing away from one another. And so in terms of, if you look at it like a Newman projection, the bromine has to be, let's say, there, and the hydrogen there. They need to be in the same plane, right? Periplanar, but pointing away from one another, and therefore anti-periplanar. Basically, it has to do with the orbitals. It has to do with the fact that this bonding orbital of the hydrogen will overlap with the anti-bonding orbital of the bromine, and therefore the electrons in this bonding orbital will kind of dance out and into that anti-bonding orbital of the bromine, thereby making this proton more acidic and weakening this bromine bond. That's why it happens. However, in some molecules, as we see in this case here, because here's the bromine, and you can clearly see there's not going to be any hydrogen that's anti-periplanar to this bromine at all. So so it's very tempting to select E as there is as the product. But basically, what this question is trying to test you is there's sort of and I think there's many universities that probably don't even teach this at all. But in some rare cases, like a constricted molecule, like a bicyclic compound, like we see here, if there is no anti-periplanar hydrogen to the leaving group, then the base will grab a syn coplanar or a syn periplanar hydrogen. So in other words, now the bromine and the hydrogen are still in the same plane, but they're eclipsed. In other words, they're pointing to the same direction instead of being anti. And while this is not as favored as the anti-periplanar transition state, and therefore maybe the yield of the reaction won't be as high and maybe it will happen a lot slower, it can still happen. So the base, in this case, will grab that proton, it'll dive down, it'll form the alkene there and kick the bromine out, and you will still get your alkene product like so with the CH3 there. I apologize for my poorly drawn structure, but there's the CH3 right there, okay? And so therefore this is a kind of a rare and sort of a interesting E2 reaction. So looking at my answer keys, I can see that C clearly is the correct answer here, okay? It's tempting to say E because, you guys will have studied this and you will say, oh, I know it has to be anti-periplanar, and it's not, so therefore no reaction. But in this case, actually, it's one of those rare examples where a syn periplanar will actually work, okay? So the correct answer here is going to be C. If you have questions on this, feel free to shoot me an email. I'd be happy to explain things in more detail if I can. Good luck with your studies and have a nice day.